Now we will discuss the volume of distribution. So imagine the drug and the amount of drug are in the beaker and you dissolve it in this liquid. So the drug will distribute it in this liquid. So the amount of liquid which in the body is equivalent to the volume of distribution. So it is the theoretical volume in which drug is distributed. And as a definition or calculation, so plasma drug concentration with the Cp equal to the amount per volume. We know any concentration is like milligram per liter. So Cp, the drug amount, concentration equal to the amount per volume. And the amount here is the dose, and the volume will be the volume of distribution. From this, we can rearrange the volume of distribution. This volume will equal to the amount divided by the plasma concentration. So it's very simple. Volume of distribution equal to the dose, which amount divided by the concentration. Okay, to further explain the volume of distribution, so we mentioned that the plasma drug concentration equal to the dose divided by the IV, which is the amount per volume. So we need to get a relation between the drug concentration in blood or tissues compared to the volume of distribution. So if the VD is low, this means the CB is high because there is inverse relationship between both. So if the volume distribution is low, so the drug concentration will be high, and this is the concentration in plasma. And the drug will stay in plasma most of the time, and the drug concentration in tissue will be small. And when VD is high, so on the other hand, the plasma concentration will be low. So plasma drug concentration will be low, so the drug will distribute more in the tissues. So if we have two drugs, drug A and drug B, and we give both in the same dose, which is 10 milligram per 10 milligram, and both have different distribution. So drug A having 20% in plasma and 80% in the tissues. So, and we measure the drug concentration in plasma, we will get 1 milligram per liter. So the apparent volume of distribution, we mentioned it is the dose divided by concentration. So it will be 10 milligram divided by the 1 milligram. So volume of distribution will be 10 liter. For drug B, it have different distribution, 50% in the plasma compared to 50% in tissues. And we measure the plasma concentration. It was 2.5 milligram per liter. So again, the volume distribution will be the dose divided by concentration, 10 milligram divided by the 2.5 concentration. So we will get 4 liters. So we start with two drugs with the same concentration, and we end into different volume of distribution. This is according to the ratio of distribution in tissue and plasma. Okay, what are the practical application of the volume of distribution, or how can we use it in the clinical practice? So we can determine the plasma concentration after an IV loading dose. So we can give an IV loading dose. So we can determine the plasma concentration without measuring in the blood by using the equation of concentration equal to the loading dose divided by the volume of distribution, where C is the plasma concentration that we need to calculate, and volume of distribution is constant for each drug. So we have a specific loading dose, and we can know from that dose the concentration in the plasma. The other thing is we can determine the loading dose if the plasma concentration is known. So it is the opposite. We know the plasma concentration, Vd, is constant, so we need to identify how much loading dose needed to reach a specific concentration in the blood. In this case, we will rearrange the solution, the equation, by multiplying C by volume of distribution, and this is for the IV route if the F equal 1. So the whole dose reaches circulation. So if we have this working example, target concentration is 10 milligram per liter and volume of distribution is equal to 40 liter. To calculate the loading dose, we multiply the concentration by the Vd, which is 10 by 40. We will get 400 milligram. So we need a 400 milligram to reach a concentration of 10 milligram per liter in the blood. Another factor, if we have an oral dosing form, for the dosage form, F equal, like this example, equal 0.7, means that not all the dose will reach circulation, so we must consider the F factor in this calculation. So we will have the same equation, C multiplied by Vd, but we will divide by the factor of the bioavailability factor. So 10 milligram multiplied by 400 divided by 0.7, we will get 571.4 milligram. So this is a loading dose to achieve the same concentration of 10 milligram per liter in the plasma. And it's obvious that this loading dose in the oral formulation will be higher than the IV because of incomplete absorption.